This week we began Unit 3, which is solving systems of linear equations. We're going to find 3 different ways that we can do this. We can solve systems of linear equations by graphing, and then we'll take a look at 2 algebraic methods, substitution and elimination, later this week. Let's nail down first what it is that we're talking about when we say a system of linear equations. For a system of linear equations, we're talking about more than one linear equation considered together. If you think about a simple linear equation such as x plus y equals 5, we can come up with literally an infinite number of solutions. 1 plus 4, 2 plus 3, 5 plus 0, negative 2 plus 7. If I give one, you can give another one. If we want one value for x and y to solve that equation, we actually need a second equation to nail that down, both in x and y. Secondly, when we're talking about a solution for a system of linear equations, when we use solution casually outside of school, we usually mean it to say the answer to a problem. Remember, in math class, it means something specific to us. Solution is the value of the variables that make both equations true. When we're graphing the system, the graph is just a tool to help us get to the solution. It just so happens to be a very visual one. When we graph the system, the solution is represented by the point or points of intersection of the 2 lines. Let's take a look at one way that we might be able to do that. So solve a system by graphing. And we have 2 example equations. 2 equations in this example. 3x minus y equals 3, x plus 2y equals 8. In Unit 2, we looked at a couple of different ways that we could go ahead and graph an equation. We could make a table of values and fill in 5 x's, find 5 ordered pairs and plot those points. We could put it in slope-intercept form and use the slope and y-intercept to be able to graph, or we could find 2 points by taking the x and y-intercept. With points on both lines, that means it solves both equations. It's our solution. Now, what happens if my graph is a little bit sloppy, or I graph it incorrectly altogether? Say I ended up drawing this graph, and I think that this is my solution. Well, here's one way I can know for sure. I can take my x and y value that appears to be the intersection of my graph and plug it back into both equations. And as we walk on through, we can see that this checks, and so does this. The solution, the ordered pair 2, 3 is the solution to our system. Note that as we go on along, remember, the equal sign is a very powerful statement. It says whatever's on the 2 sides of this equal sign have exactly the same value. Right now we're checking for that. So there's a little question mark above each equal sign until we verify 8 equals 8. So here's our procedure. We estimate the solution graphically and then check the solution algebraically. Let's take a look at a couple of examples. Solving the system, negative x plus 4y equals 2, 2x minus 3y equals 6. If I go ahead and take x and y intercepts of both, I think that'll be a quick and easy way to do this. So the opposite of 0 is 0. 4y equals 2, divide by 4. My y-intercept is positive 1/2. It's not ideal, but if we put this in slope-intercept form, we'd have the same result. So we're going to go with this. When I substitute 0 in for y, opposite of x equals 2, so x equals negative 2. Oh, it's going to look something like that. If I do the same thing with 2x minus 3y equals 6, so negative 3y equals 6, y equals positive 2. Y is going to equal negative 2. And my x value is 3. Now, at first glance, these lines look like perhaps parallel Are they going to intersect anywhere? It's hard to tell. So let's go ahead, and if I had a straight edge, we'd use a straight edge for this. But now I can see that it appears that they intersect at this point. Now our next job is, we can't just say, well, they intersect there. We need to be able to name that point. Unfortunately, we have an ability to do that. Any point on the coordinate plane, we can name its x coordinate and y coordinate. So from the origin, 1, 2, 3, 4, 5, 6, and up 2. This is the point 6, 2. So to check that, negative x plus 4y equals 2. So the opposite of 6 plus 4 times 2 should equal 2. Negative 6 plus 8 equaling 2. Well, that's positive 2 equals 2. And that checks. Let's try it out in the other equation. 2x minus 3y equals 6.